Let's say that we have three vectors A, B, and C, and we know that vector A plus vector B is equal to vector C. Now, given this, I have some interesting questions. Can you construct a scenario where the magnitude of vector C is equal to the magnitude of vector A plus the magnitude of vector B And can you also, using potentially different vectors A and B, construct a scenario where the magnitude of vector C is greater than the magnitude of vector A plus the magnitude of vector B? So I encourage you to pause this video right now and try to do that. Try to come up with some vectors A and B so that when you take their sum, that the magnitude of the sum is equal to the sum of the magnitudes. And also see if you could come up with some vectors A and B so that if you take the sum of the vectors, that the magnitude of the sum is actually greater than the sum of the magnitudes. So see if you can come up with that. Well, I'm assuming you've given a go at it and potentially have gotten a little bit frustrated, especially with the second one. So the only way, let's actually just draw some vectors. So if you have vector A like this, and let's say vector B looks something like that, then A plus B, let's see, we can just shift this over, copy and paste. A plus B is going to look like this. A plus B, or vector C, I guess we could say, is going to look like that. And notice, these three vectors always form a triangle. And if you have a triangle, one side cannot be longer than the sum of the other two sides. Think about it. If you wanted this to be longer, what you could try to do is maybe change vector B in a way so you're pushing it further and further out. So maybe you could, if you changed your vector B a little bit, you can get this vector C to be longer and longer. So maybe if you made your vector B like this, maybe your vector B would look something like this. Now your vector C is getting pretty long, but it's still shorter than the sum of these two sides. And to make it equal to the sum of these two sides, you essentially have to make these two vectors go in the exact same direction. So to make it equal, you have to have vector A looking like this, and you got to change the direction of vector B, or essentially construct a vector B that's going in the exact same direction. So it's going in the exact same direction. Only in this circumstance will you get this scenario, where the magnitude of vector C is equal to. So really the largest that the magnitude of the sum can be is the sum of the magnitudes. And that only happens when these two are going in the same direction. So these are going in the exact same direction. This right over here is impossible. You can never get one side of a triangle being longer than the sum of the other two sides based on what we just saw. Now you're probably saying, well, what about the circumstance where the magnitude of our sum is less than the magnitude than the sum of the magnitudes, I guess I could say. And this is fairly typical. This is pretty much always the scenario. This is what's going to always be the case when the vectors are not going to be when the vectors are not in the same direction. So if someone drew a vector like this, let me draw it a little bit straighter. If someone drew a vector like this and a vector like this, these clearly are not going in the same direction. So the sum of these two vectors, the magnitude of that, is going to be less than the sum of these two magnitudes. So for example, if the magnitude here is 5 and the magnitude here is 3, then we know that if we were to add these two things, let me just show you. So copy and paste. So if we were to actually, let me just cut and paste so that we can clean things up a little bit. So cut and paste. So let's add these two vectors. So we know that the sum of these two, which is going to be this vector right over here, its magnitude is going to be less than 5 plus 3, is going to be less than 8. The only way that this magnitude could even get to 8 is if these two vectors went in the exact same direction.